So just as a recap, we talked in the last video about the problem we've got. We've got these things called sequences. Sometimes we're interested in adding up a sequence to a particular number of terms. Okay, so here's the general sequence up the top here. A plus D, A plus 2D, A plus 3D would be the next one, and so on. What if I want to add those up together up to some number of terms? Okay, there is going to be a last one in this case because this sum can't go on forever, otherwise the answer would be infinite. So I'm looking at the sum to some number of terms Sn. Now I could call the last term Tn, okay, the nth term of this sequence. I'm actually going to give it a different name in this case, just so that we don't have big Tn's lying around everywhere. I'm going to call it L. So this last term, I'm going to call L for last. And just to help us out here, I'm actually going to put the second last term in. Okay, so I'm just going to move that over. If L is the last term of the sequence, then the second last term has to be L minus D. Okay, just have a think about that. The last term is L, so the second last term, the gap between them has to be D. So if I take D away from L, that'll end me up there. Okay. So what I've written here is the sum that I want to find. Okay, the sum to n terms of this sequence. And the last term L here is n. Okay, is the nth term. Now, we're looking at a formula to do this. We don't want to have to do every little sum here separately. That would suck. So what I'm going to do is I'm actually going to rewrite that line exactly the same. The only difference is I'm going to flip it. Okay, so I'm going to write it in the opposite order. So the first term that I'm going to write is L. The next term that I'm going to write is L minus D. The next term, okay, would be L minus 2D. Okay, that would be the term coming just before that, even though I didn't write it on this line. That's going to continue on. Okay, somewhere in here, the next term that I haven't written in here would be the A plus 2D. The second last term that I'm going to write out this time is A plus D. And the last term I'm going to write is A. Now, there's a reason that I have set this out in this way. These two lines are exactly the same. Just change the order, and I'm allowed to do that. What I can do now is add these two together. So I'm actually going to add the left-hand sides of these equations together, and I'm going to add the right-hand sides of these equations together, okay, all the way along, to get another expression. And this is going to be quite a neat little expression that comes out. Sum to n terms plus the sum to n terms is 2 lots of Sn. Okay, here I'm going to have an A plus L. So that piece there is going to give me A plus L. Let's have a look at this bit here, okay, and do this sum. Okay, I'll just write it over to the side here. I've got A plus D plus L minus D. Let's have a look. That's A plus D plus L minus D. It's pretty clear that those two D's are going to cancel out, and I get A plus L. That's interesting. This one here is also A plus L. Now what I'm going to do is I'm just going to put each of these in a set of brackets, because that's going to be helpful to us. Let's have a look at the next set. Look at this sum here. I'm going to have A plus 2D plus L minus 2D. have a look here. Those are going to cancel out, and I get A plus L. Okay. A plus L goes here, again in brackets. You can see pretty clearly that each of these additions that I'm doing this way will result in A plus L. So that's going to keep going. I'm going to get A plus L, A plus L, A plus L. It's going to keep happening all the way up here. So I get right to the end. Let's have a look at these last ones. Make sure that it works out the same. L minus D plus A plus D. Minus D plus D, they're going to cancel out. I get L plus A, or I could write it around the other way, A plus L. Great, still working. A plus L, and this last one, L plus A, well, I could also write it as A plus L. So I've got here A plus L plus A plus L plus A plus L, and so on. The question is, how many of these are there? Well, this was a series to n terms. Okay, L represented the nth term. So it makes sense that if I counted up all of these, I'm going to get whatever n is. There are n of these A plus L's along here. There are n terms here. So it follows, if I have a bunch of things added together and they're all exactly the same thing, I can write this as n lots of A plus L. So I've got that 2 lots of the sum to n terms is equal to n outside of A plus L. Now I'm interested in what Sn is, and this is just an equation. If I divide by this 2, I get n on 2 outside of A plus L. And this is my formula for the sum to n terms of an arithmetic series.